All right, let's look at this problem called unique paths 3. Let's have a read. You are given m cross an integer array grid where grid ij could be 1 representing the starting square. There is exactly one starting square. 2 representing the ending square. There is exactly one ending square. 0 representing empty squares we can walk over. And minus 1 representing obstacles that we cannot walk over. Return the number of 4 directional walks from starting square to ending square that walk over every non-obstacle square exactly once. Okay, so this is an example. From this starting square to ending square, we have to find a path, or we have to find a number of such paths that will start from this point and at this point and cover every single non-obstacle square. So for example, definitely one path is go right, 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 then left, then sorry, then down, then left, then down, and then right, right. How many such paths are there? So this is another. So the constraints are starting point and ending point are fixed. So you have your fixed starting and ending points. Uh, don't involve obstacles in the path. So first thing we have to find out what is the starting point and end point, right? That's like a basic condition. So let's do that. So let's say we have start x, start y, and x and y is that's a 0. So we go through the array, we go through the grid and first find those out. So I equals to 0, I less than grid dot length, I plus plus, and then right, we need to walk and find out which is the starting point, which is the ending point. So if this is 1, then this is the starting point, right? So we go start x equals to x, start y equals to y, and then the for the ending point there will be if it will be 2, right? So we go then it is ending x equals to 0, sorry, equals to x, and so that's clear. So now we have our start and end point. So this condition is satisfied. This condition we can now check for either by the value, which is 1 and 2, or now we already found the exact points, right? So that's great. Now the other bit is don't involve obstacles. So let's also find out how many obstacles are there, right? So our total path's length. So our total path would start from starting point and at ending point, and its total length would be the number of nodes in the grid minus the number of obstacles. So let's also find out number of obstacles. So maybe let's do obstacle count and let's make it 0 to begin with. And other cases, if the grid of ij is minus 1, then it's an obstacle, right? So if grid ij equals to minus 1, then you do your obstacle count plus plus. So now you want to require your total path length. Let's also use that as a, so let's also use it here. So you want your required path length, right? And you set this required path length to, so you do, now my required path length would be total number of nodes, which is m cross m times n, minus the number of obstacles, right? Okay, interesting. So let's type it down. Obstacle count. All right. So now we know what path length we want. So now if we do a DFS starting from the starting point, and we'll keep doing the DFS till we reach an ending point, and when we are at the end point, we'll check what is the current length, and if the length is equal to the required path length, then it matches the criteria, right? So okay, so then let's just do like a DFS grid, and we do the DFS from starting point and ending point, and we will probably because we have like we don't want to go back like one to this point and then going back. We need like an in path array or something, or we could do that. We could use a trick where we could use some trick where we modify the value of the grid to indicate in path, right? Uh, we can set grid of ij to some value. Let's so 0, 1, 2, and minus it is occupied. So let's use 3, right? So this way we save a little bit of space in using an auxiliary array. This is some trick that we used in some previous problems as well. Okay, so now let's see. And eventually we're going to return the number of different paths, right? So maybe initialize that as like the whole thing. So number of paths to begin with is 0, right? Now, now let's do the actual DFS. So here you're passing first is grid and some point x and y. So obviously, first thing we want to check is some condition that we don't want to go further with. So obviously, if your boundary, so if you're less than 0, y is less than 0, x greater than equals to red dot length, or y is greater than equals to grid 0 dot length. Right, these are some corner cases. Like these is when you're out of the boundary. Other than that, you don't want to walk through obstacles. So if grid of ij is an obstacle, then you don't want to use it. Or if it's already in path, right? And for that, we are assuming that grid of ij we would have set to 3, right? So if it's already in path, that's another thing. What else? We need to maintain like what is the current length of my path. Like we don't wanna go for a how to say, can our path's current length ever be greater than the can it ever be greater than no, it can't, right? That we're sure about. But there is one thing which is you still need to know your current length. So let's pass that as 0 and let's call it current length, right? And I was thinking of adding this condition called current length should be if current length is greater than equal to path, then there's a problem. But that should never happen because the number of nodes in the path itself is equals to current length. So that should never be satisfied, right? So this is fine. So if all this happens, you return, right? Otherwise, you're gonna mark it visited. So you do grid of x y equals to 3 to mark it visited. Let's also save this original value though. It could be 1 and 2 as well, right? If it's starting and the ending point. So we'll restore it to the exact same value. So we can do this, and um when you add some node to or visit some node, your current length is going to increase, right? So current length plus plus. And at the end, you're also going to replace this. So you want to do, you're going to set it to its original value and reduce the current length back. Between that, you want to do DFS and go through all the 4 directions. But there is one case where you want to terminate, which is if your grid of XY is the last node. So if we've saved it in value, so we could do, we can just use the value itself. So if value was 2, that means it's the AND node, right? So, and if it's not the AND node, then obviously then it's easy. Then you just want to do DFS. So further DFS, right? So further DFS, let's look at the 4 different directions. Let's add it here. So maybe we have these different moves or directions, right? So the directions are, there are 4 different directions you can walk in. You can go -1, 0. You can go 0, -1. You can go 1, 0, and you can go 0, 1. So these are the 4 different directions that you can go in, and for each direction, so just go in all 4 directions. So for each direction in directions, You want to do DFS. So you pass in your grid x plus 0, y plus 1, and your length. That's what you will do if it's not the AND node, and you keep continuing. But if it's indeed the AND node, then you want to check if you have covered all paths or not, right? So if um, current length equals to the required path length, then your number of paths would increase, right? Otherwise, it's all fine. Yeah, so that's my code, right? So you do DFS, you reach the end node, you check whether you have covered all paths or not. If not, then you just okay. But if you're doing end node, you're not gonna go back. So you're just gonna go here and consider other paths. And if it's not the end node, then you keep doing for the DFS till you reach the end node, and that is it. So let's run. Fix compilation errors. Line number 27. Invalid method declaration. Return type required. Okay. Void here and run again. Fix some more errors. Line number 14. This is INJ, so IJ, and let's do here also INJ, and this is good. All right, let's see if there are any more errors. Okay, there are. Cannot find symbol. Okay, somewhere we have used IJ, somewhere we have used X and Y. Let's fix that. So here you wanna use XY. Here you wanna use XY. All right, let's see what other errors are there. Required path length variable is this. Copy it here, use it here, and again. And we get a wrong answer, unfortunately. Let's try and debug why there is a wrong answer. So one test case passed, other two failed. Let's look at the failing one. Let's look at the first example. So this is the first example. Uh, the expected is 2. Obviously, one path I can definitely see is this. The other path probably is this, right? So I can just by looking at it, I can see the two paths. So what happened? Let's quickly have a run through. So we would have gone through the so that we are walking this loop correctly, and ij is 1, ij is 2, xy, xy, ij, and you got the obstacle count. So the required path length has to be correct. You pass in this, you return path. All right, let's look at these conditions. This is boundary condition, this is correct, this is correct, this is correct, this is correct. Grid of xy equals to -1 is fine. You don't want to walk through obstacle. Grid of xy equals to 3 is a visited node, so that is also fine. Um, so now you take the value, you mark it as visited, increase your length, and at the end you replace it back with the original value and reduce the length. That's also good. And then let's look at in case of directions we have missed something. So -1 0 0 -1 1 0 0 1 is also correct. All right, so just by looking at it, not able to find. So let's use some prints and debug it further. So let's see how many times we reach this AND node, and whenever we reach this AND node, let's print the uh, path size. So let's do this, and let's see how many times, how many different path sizes we are getting for this. So we are obviously we need so this is like a 4 cross 3 12, so we need path size as 11. We got it once here, and now wait for by 9 is when we sort of break and never moved further. Hmm. All right, let's try and debug more. It's a good debugging exercise here. What can be the bug? Where can the bug come from? Let's have a look again. So definitely this is correct. The required pattern is correct because the one that we're getting 11 that works. So the problem has to be in the DFS then. X, Y, X, Y. Can't see anything obvious, definitely. One problem could be that you're, you're not considering one of the directions, but I can see all four are correct. So minus 1, 0, 0, minus 1, 1, 0, and 0, 1. So we are using all four directions, and this is also correct. Um, is it we are returning from some path incorrectly? I mean, all of these conditions are quite basic. We're using 3 for visited, so if it's already visited, we don't want to visit it again. If it's an obstacle, we don't want to walk through it. And then for everything else, we want to include them into the path, include them into the current length. Where did we mess up? Is it the value? Is the value to the adding node? Yes, and it is the adding node, so that's good as well. Now there is only one way to solve for this, which is for every point print the grid, right? And that will tell us what we have, what is the exact path that we like. What are the different paths that we considered? So let's maybe print the different paths here. So we'll do print grid. Let's call it grid, and let's add this function. Okay, so row, for each integer cell in the grid, so we print it, and we then maybe also after every row add a new line. Yeah, obviously this debugger would have helped, but all right, we don't have the debugging option. And let's see, what did we miss? Int array cannot be converted, can be converted to int. Um, where the problem is coming from? It is called print grid. All right, run again. Integer array cannot be converted to int, line number 76. Okay, it's row. All right, now let's see what was the issue. So when we, so that was one of the paths, right? One, two, three, four, five. Okay, so we don't know which path it took, but basically, um, this, this, and then this is one, and then you go. I don't even know how you can reach this path. Yeah, how is even this possible? You have to start from here only. I don't know how it reached. This is a bit unclear for sure. That's a bit unclear. So I mean, you can do this only if you do something like this, right? Otherwise, I'm not quite sure how you do this, but okay, let's see this one. So is the start, that means that is the starting point correct here or what? Are we looking at the wrong starting point here? One represents the starting square, start x, start y, and we pass, do we send the correct things? Ah, okay. So this is the silly thing that we did. We gave some wrong path. We gave some wrong starting point. All right. Um, yeah, everything is accepted now, and it makes sense. Okay, let's remove the print and submit. Okay, submit. And it seems to work. All right. The time capacity doesn't seem very good though. Is there something better that we can do to fix the time complexity? Are there some more prints somewhere maybe? Oh, maybe there are some more prints somewhere. Let's remove this. Okay, let's submit again. Yeah, all right. It was just a print. All right, seems good.